Yeah, hi everyone, I'm Isaac. I am leading you into another topic which is logarithms. Logarithms. Now let's move on. What are the content? Now number one, deducing logarithm from indices and standard form. Number two, definition of logarithms. Number three, anti-logarithms. Number four, the graph of y equals to 10 raised to power x. Now, there is a close link between indices and logarithms. Yes. Let's say 100 equals to 10 raised to power 2. Of course, you know that is the standard form of 100. This can be written in logarithmic notation as log 100 to base 10 equals to 2. Are you seeing it now? Now let me show you so that you get it right. So this is the 100. Are you seeing it? And then this is the base. Are you seeing it? And this will equals to the power. That's the format. Are you following? That's the format. Now let's move on. Similarly, 8 equals to 2 raised to power 3, of course, you know. When you want to write it in logarithmic notation, it can be written as log 8 to base 2 equals to 3. Are you following now? Yeah. In general, n equals to b raised to power x in logarithmic notation is log n to base b equals to x. We say that the logarithms of n in base b is x when the base is 10. When it's base 10, and the logarithm is known as common logarithms. All the logarithms to base 10 is called common logarithms. Are you following? So let's move on. Now the logarithms of a number n in base b is the power to which b must be raised to get n. Are you getting it now? So let's move on. Now, two parts of logarithms. What are the two parts of logarithms? Number one is integer, that is characteristics or whole number. While number two is mantissa, that is decimal point. Now, which you are going to see in a moment. For instance, if you have 27.50, you can see that it has both integer and mantissa. You are going to get it now. When you have 27.50, now the first number before decimal is called characteristics or integer or whole number. While any other numbers after decimal point they are mantissa. Are you following? So let's see what we are talking about. No, integers are 27. You understand now? Which is character. While decimal, which is mantissa, is 50. You are getting it now. So any number before decimal point are integers or characters. While immediately after decimal point they are decimal or mantissa. Now using standard form to write, which is written as capital A times 10 to the power n. This is the format for standard form. Now you are going to see that 27.50 equals to 2.75 times 10 to the power 1. Of course, you know this one. When we were doing standard form, you can go to standard form and indices lesson on our YouTube channel to get that one if you don't know how to write standard form. So that is the standard form of 27.50. Now the power of 10 in this standard form is what? Is 1, which is, you are getting it, is the characteristic that we are talking about, which is 1. So that is, if we are writing 27.5, the log of 27.5, you are going to have one character. Are you getting it? From this, when you have written your standard form, you only have one character, which is shown from your standard form. Are you getting it? Because 27.50 is in standard form to be 2.75 times 10 raised to the power 1. Are you following? And that one is characteristic that we are talking about, which when you are writing it in logarithmic notation, is going to be log 27.5, which has one word character. I think you are getting the point clearly. So let's move on. Now the Mantissa can be read from 4-figure table. The Mantissa can be read from 4-figure table. Are you following? So let's go. Now this 4-figure table is at the back of your general mathematics textbook, and you can still buy while 4-figure table, while NEPO normally give it for free. So you can get that one. Below is a row of 4-figure tables. We are going to see it in the next page. So let's move on. This is the row of 4-figure table. We just pick number. This actually is from 1 to 100. Are you getting me? But we just pick 27 because you know we are using log 27.5 as example. You understand now? So let's move on. Now to check for log 27.5. Now look for the first 2 digits, which is 27. Look for the first 2 digits, which is 27 here, and then you know it's 0.5 under 5, which is now going to be this one. Are you following me now? 27 under 5. If to say we still have like 3 or any number here, are you following me? We are now going to say difference 3. These are differences. Are you getting me? Sorry, let me delete this so that you get what we are saying, and delete this. So it's now going to be difference 3. Difference 3 is the same thing, sorry. Difference 3, which is 4. You now add to a 4 3. You add 4 3 9 3. Are you getting it? Plus 4. But there is no other number here, so we just stop at under 5. I think you are getting this thing. You just stop at under 5, which we are doing now. Now look across the row of 27 and stop at the column with 5, which I have just said, which is here, then at the top. Now this gives the figure to be 4393. Am I correct? Yeah. And then hence log 27.5 is now going to be, you have it is one characteristics, which is one integer. This is 1, then 0.4393 that you got. That's how to write it. You understand? The first thing is to get the characteristic using standard form. Are you following? When you get the characteristic using standard form, then you are going to go and look at the figure on your 4-figure table, and whatever you get is going to be after the decimal point, which is Mantissa. Are you following? So let's move on. Now for example, now let's take this example. Find log 275.2 using 4-figure table. Let's go. Now solution. In log 275.2, what is the standard form of 275.2? The standard form is 2.752 times 10 raised to the power 2, meaning the character or the characteristics or integer is 2. Now the characteristic is 2. Then to find Mantissa now, which you are going to get now, we will use the 4-figure table to find the Mantissa. And then now look across the row of 27, then stop under the column of 5 at the top. Then this will give you 4393. This is what we are talking about. We have done it already. Just go to 27. In this place we have 27, 28. Are you seeing 29 straight to 99? So we just pick this one out of all the tables. So since we are using an example like this, it's now going to be, you understand, that log log 27 under 5 difference 8. Now you now go up to 27. When you get to 27, go to under 5, which is 4393. Are you getting it? But it still remains 2. Now go to difference 2, which is this 2, which is now the answer is 3. Now add 3 with 4393. Am I correct? Now let's move on. Add and go to the last part, which is called difference. Are you following? Which is now going to be the difference is of 2, which is now going to be 3. For you to get what I'm talking about, you get it now. Difference 2 is 3. Are you getting it? That means you are going to add this with under 5. I think you are getting it. So you add them together, you plus them together. So that's what you are going to do. I think you are following quite well. So that's why we get the difference 2 will now be 3. Now add 3 to Mantissa, which is 4393. Now will be 4396. Hence log 275.2 is 2, which is the character that we got. Point all the Mantissa, which is 4396. Now let's go to antilog. Antilog is the opposite of logarithm. Anti-logarithm. Now let's go. If the logarithm of a number is given, one can determine the number for the anti-logarithm table. Are you getting it? Now let's go. Example. Find the anti-logarithms of the following. A 0.5670, B 2.9504. Solution. A 0.5670. Now the integer is 0. Of course, you know that the integer here is 0. We can't count any character here. There is no character. Now, using table that we have shown you, go to number 56 now. You know, it's only Mantissa that we are going to have here. Now go to number 56 on your logarithm table. Number 56. Then you stop at the column under 7. Are you getting it? And then you stop at the difference 0. You are getting it. Now, since the integral part of the 0.579070 rather is 0, it means that the antilog will be 37. By the time you look at it, it's going to be 3707, which is written in the standard form. In the standard form of the power of 10, and the power of 10 is what? It's 0. You understand now, which is just 1. Are you following me? Now that this is the antilog of 0.5670 is 3.7070. I know you understand. This is 7, it's not 9. This is 7, it's not 9. You know, this is the question. Are you getting it? They say you should find the antilog. You just go to antilog table, and since there is no character, are you getting it? You start from Mantissa, which is 56 under 7 difference 0. What you will get when you look at your polygon table is 3707. Are you getting it? And when you got this one, then of course you know that character is 0, which is 10 raised to power 0, which is 1. Are you getting it now? So that's why you are going to get 3.70.7. Do you understand now? Because it's just one character. It's just one character. So let's move on quickly. Now, let me clear this. Now let's move on. Now that the final answer is 3.707. Just go and study your polygon table I have explained to you. We have the first column to be integers, the number that you want to look at. from 1 to 99 in your logarithm table, and then in your anti-logarithm table it starts from 0 point down. You are getting it. And the second column is what we call under. So those column is what we call under, and then the last column is difference. So you will get it when we are going. Now we are going on the graph of y equals to 10 raised to power x. Use of logarithm table and anti-logarithm table in calculation involving number 1 multiplication, and number 2 division, number 3 powers, number 4 roots. I want you to note this. Now number 5, application of logarithm in capital market and other real life problems. Now we use logarithm in calculations involving powers and roots. The basic principle of calculation using logarithm depends strictly on laws on indices. Recall from previous lessons, that is indices, that log mn, that is m times n, will be equal to log m plus log n. Of course, you know, log m divided by n will be equal to log m minus n. Hence, we conclude that in logarithm, when numbers are multiplied, we add their logarithms. When two numbers are added, we subtract their logarithms. Are you following? I repeat, when numbers are multiplied, we add their logarithm. When numbers are divided, we subtract their logarithm. Now let's go to multiplication of numbers using logarithm tables. Multiplication of numbers using logarithm tables. Now let's move on. Now example 1, evaluate without using calculator. 92.63 times 2.914. Let's go. First thing is write the titles solution. The first thing is to write, this is the number, the logarithm. Are you following now? Now you now write the standard, or this is the number, the standard form, and the logarithm. Are you following me? So this is what I'm talking about, so that you get what once and for all. This is the number you want to find, you want to evaluate. Are you getting me? This is their SD standard form of those numbers. Then this is the log number that you looked at in your 4-figure table. Do you understand now? Now this is the operation that we involve, since it's multiplication. Since it's multiplication here, the operation in logarithm will be plus, which is add. Are you following my point? Now go write the standard form of 92.23, which is 9.263 times 10 is to power 1. Are you following me? And then when you write the logarithm, that means the character of this number is what, of these figures, is what? 1. So that is why you write 1 here. That is why we write 1 here, because the character is 1. Are you following? Now, having done that, you now go and look at 92 under 6 difference 3. You go to number 92 rather, and trace it across the column 2 under 6, and then go further to the end of the table to difference 6. Add difference 6 plus 92 under difference 3. What you see in difference 3 plus 92 under 6. You understand? Together you are going to get 9667. Are you getting it? Now let's do the standard form of 2.914. The standard form of 2.914 is 2.914 times 10 raised to power 0, because there is no character here. Are you getting it? So that's why we get 0 here. You now go to the 4-figure table under logarithm. You see the number 29 across under 1. So you look at the number that is there, write it down, then go far end to difference 4. What number you see under difference 4? you are now going to write it and add it together with that number. You are going to get 4645. That's why you get this. Now, since the operation between them is times, then in logarithm it will turn to addition. So you now add the two log together. When you add the two log together, you get 7 plus 5, 12. You write 2, carry 1. 7 plus 4, you write is 11. You write 1, carry 1. 7 plus 6 is 13. You write 3, you carry 1. 10 plus 4 is 14. You write 4, you carry 1. 1 plus 0 is 2. That's why you get this. Are you following? Having got this, to convert it to the number, you are now going to go and find the antilog of not 2. You must remove this 2 when you want to find the antilog. This 2 is not the amount the Mantissa, it's just character, it's not the number. So this is what you are going to look for in your antilog table. You now go to antilog table. Are you following me? You now go to antilog table, which is this one now. Log, which is 2.4312. Let me show you 2.4312. And the antilog will be, you now say 43 under 1 difference 2. 43 under 1. This is where you are going to start for your 43 under 1 difference 2. So when you see 43 under 1, you write it down and go far into the difference 2. The number you saw there, you add it to 43 under 1. You are now going to get 2699. When you get 2699, are you following? Are you following? You know the character is what? 2, which is now going to be 2.699 times 10 raised to power 2. And then when you say 6 times 10 raised to power 2 in ordinary form, it is going to be what? 269.9. Am I communicating? Okay, so let's move on. Therefore, 92.63 times 2.914 equals to 269.9. Let's go to division numbers using logarithm. Now, example, evaluate 357.2 divided by 87.23. Now, doing the same thing as the example above, you are now going to have the number, the standard form, the log, and operation. Are you getting the point? Now, what is the first number? Is 357.2. What is the standard form of 357.2? The standard form of 3.5.2 is 3.572 times 10 raised to power 2. Am I correct? Yes. If you still don't understand how we write standard form, go and check our previous lesson on that. That is, this is 1, 2. This is where the point will be. Are you getting that? I'll get 3.527 times 10 raised to power 2. It means that the character or the integer is actually 2. That's why we wrote this 2 here. You will now go to your 4-figure table. You will look at 35. Are you seeing me? Under 7. Are you seeing me? Difference 2. You write 35 under 7. What do you see on 35 under 7? You write it down. And then what do you see at the far end of difference 2? You write it down. You add them together, you will get 5529, which is 5529. Are you following? Then what is the operation? Because since it is a division, then the operation in logarithm will be what? Subtraction. Are you getting me? That's what I am talking about. So, having done that, let's go to the second one, which is 7.2. What is the standard form of it? 7.23 is 8.723 times 10 to the power 1, meaning the character of this figure is 1, and that's why we write 1 here. You now go to your 4-figure table, you look at 87 under 2 difference 3. When you get to 87 under 2, you write it down. And you go to difference 3, whatever under the difference 3, you write it down and you add them together, you get 9406. That's why we get 1.9406. And the operation, of course, is subtraction. Now therefore you are going to subtract this one from 2.5529, so which is now going to give us 0.6123. So let's move on. That's what we got. Then you are now going to convert it into your antilog, which is up here. Now the log, the antilog standard form, and the number part. You want to turn it back to the number. You know, from number to log, and from log back to number. That's how to do it without calculator. You do the evaluation from number to log, and then from log back to number. That's how you get your answer. Now the log that you get by subtracting the first from the second from the first from the second, now is 0.6121, and meaning that the character here is 0. Are you following my point? Yes. Now which is now going to be, when you look at 61, now you are going to anti-log table. You leave log, you go to anti-log table. You now go to 0.61 under 2 difference 3, you get 4096 for your anti-log. And then you know the character of this is what? Is 0. That's why you get 4.096 times 10 raised to power what? 0. Are you getting it? And the 10 raised to power 0 is 1. That's why you get 4.096. Therefore 357.2 times 87.2 is 4.096. Are you following? Divided rather. It's not times, so it's not times. Please, this is not times. It's wrong. Of course, you know we were talking about division of number using logarithm. So let's move forward. Now, calculation of powers using logarithms. Now, study these examples. At times, calculations can involve powers and roots from the laws of logarithms. We have a log m raised to power n is equals to n log m, while log m raised to power 1 over n is equals to 1 over n log m. Are you getting which is log n root m? So then C, log m raised to power x divided by n is equals to x divided by n times log m, which is x log m divided by what? N. Are you getting the point? So now example 1, evaluate the following. 53.75 raised to power 3. We are going to do the number standard form, the log and the operation. We are now going to do number standard form, log and operation, which is 53.7 raised to power 3. What is the character of 53.75? Which is the character is that is standard form is 5.375 times 10 raised to power 1, meaning the character is actually what? 1. That's why we get 1 here. And then you go to your logarithm table, you look at 53 and you write under 7. Are you getting it? Write it down. Then difference 5. What is under difference 5? You write it down and add the two together, you get 7304. That's why we got this. But however, you know that is raised to power 3, and when it's raised to power 3, you multiply. That means we are going to multiply this log by 3. How when you multiply this one by 3, you get 5.1912. Are you following now? So that is what you get. Now you're now going to go back to the number. You know, when you are dealing with the calculation without using calculator, you are going to change number to logarithm and return logarithm back to number, and the final answer you get is correct, which you can get when you use a calculator. So log that we got just now is 5.1912, and then the anti-log will be, you just look at 19 under 1 difference 2. You know this 5 is not is a character. Are you getting it? So you start from 9, which is 19 under 1 difference 2, which you are going to get 1553. And then the standard form of this is character. You take this character to the power of 10. That will be 1.553 times 10 raised to power 5. And then when you multiply it, you are going to get 155300. Therefore, 53.75 raised to power 3 is 155300. So let's go. Calculation of roots. Calculation of roots using logarithm and anti-logarithm table. Use tables of logarithms and antilog to calculate root 5 root 27.41. Now solution. Write the number standard form log and operation 27.4 root 5 root 27.4. When you see this one, what is the character of 27.41? Which is 2.741 times 10 raised to power 1. That's standard form, and which means is the character, which is 1. So that's why we wrote this one. You now go to your logarithm table, you will check 27 under 4 difference 1. You are going to get 4380. But you know that is raised to power 1 over 5 since it's root. If it is root, you are going to divide. If it is power, you are going to multiply. If it is plus, you are going to add. If it is minus, if it is multiplication, you are going to add. If it is division, you are going to minus. Are you getting that? Those are the 4 basic operations in logarithm. If it is multiplication, you turn it to plus in your logarithm operation, and then if it is division, you turn it to subtraction, that is minus in your logarithm operation. If it is power, you turn it to multiplication in your log operation, and then if it is root, you turn it to division. But this one is root 5. That is why we divide the number that we get by 5. Now divide by 5, you get the answer to be 0.2876. Now go back to your log. What is the log? Which is 0.2876. 0.2876. The antilog, that is 28 under 7 difference 6, is 1939. And then the standard form will now be 1.939 times, you know, the character here is 0, 10 raised to power 0, and 10 raised to power 0 is 1. That's why we get 1.939 to be our answer. Therefore, 5 root 27.14 is 1.939. That is the answer we got. Now let's move on. Now example 2. Use this table to find the cube root of 218 divided by 3.12. So let's move on. Solution. The hint is this: work out 218 divided by 3.12 before taking the cube root. Are you following? Now let's move on. Number standard form log and operation. Now what is the number? We have 2 numbers. The first one is 218, the second one 2.12, 3.12. 218, when you write the standard form of 218, you have 2.18 times 10 raised to power 2. Are you following? Of course you know how to write standard form. And then that means the character here is 2. Are you getting it? That's why we wrote these 2 here. These 2 here. Are you seeing it? These 2 here. And then you now go to your logarithm table, you now look at 21 under 8. There is no difference because there is no other number after 8. 21 under 8. What is 21 under 8? Is 3385 when you check your logarithm table. Are you following now? So let's go to the second number, which is 3.12. And then what is the standard form of 312? Is 3.12 times 10 raised to power 0. That means the character here is 0. That's why we wrote 0 here. And then what is 31 under 2 is 4942. And then the operation between them is division, which is going to turn to subtraction in logarithm. That's why we subtract this one from each other, which we are now going to get 1.8443. Now, having done that, you know that what combine the 2 of them together is cube root, which is cube root. Are you getting the 3 root all the numbers, which is now going to be division. When it is root, it's going to turn to division. When it is power, it's going to turn to multiplication. Are you getting it? That's why we divide it by 3. In logarithm, root is divided. In logarithm, power is multiplied. In logarithm, division is subtracted. and in logarithm multiplication is added. So I'm repeating this for you to know. Now timesing, multiplying this one, we are going to get 0.618. That is what you got. You are now going to go and check the anti-log of this one. You know, you go from number to log and back from log to number, and that's the process, which is now going to be, what is the log, which is 0.6148. Then you are going to look at 0.61 under 4 difference 8 in your anti-log table, which is going to be 4119. Having got that, you are going to write the standard form to be 4.119 times 10 raised to power, this is 0, which is this one, and then 10 raised to power 0 is 1, then 1 times 4.119, the answer remains the same. So that is the answer. If you use calculator for this, you get the same answer. So that is what we are talking about. Therefore, cube root of 218 divided by 1.21 is equals to 4.119. Example 3. Evaluate 63.75 square minus 21.39 square. Now we can use difference of two squares. Of course, we can use difference of two squares. It's one of our classes which will be uploaded soon. That is, you have a square minus b square to be open bracket a plus b close bracket open bracket a minus b. It's very simple, and you get your answer straight away, which is now going to be like this. Are you seeing it now? Yes, you can now multiply this one, which you can use your logarithm operation. Are you getting me? That is like this, the number log and the operation. What is the number here is 85.95. The first number, which is, what is the standard form of 81.95 is 8.514. 85.14. What is the standard form of 85.14? Which is now going to be 8.514 times 10 raised to power 1. That's why the character here is 1. And then you go to your logarithm table, you check 85 under 4 under 1 difference 4, you get 9301. Are you following me? Which is now going to, you are going to get down. The second number is 4 to 42.36, which is now going to be, what is the standard form of 42.36, which is now going to be 4.236 times 10 raised to power 1. Are you getting it? That's why the character here also is 1. And then when you look at 42 under 3 difference 6, you have 60. Are you getting it now? But the operation between them is multiplication, and in log operation is going to turn to addition. So adding them together, you are going to get 3.5561. Now this number is what you are going to go and check in your Popgo table under anti-logarithm. However, you will exempt the 3 outside. So you're now going to go and look at this one, 55 under 6 difference 1. When you check 55 under 6, write it down. Then go far end right, and then check number that is under difference 1. Add them together, you are going to get 3606. And then you know the character here is what? Is 3. That is, if you want to write the standard form, it's going to be 3.36. Are you following me? Sorry, 3 point. Let me delete this one so that you get what I am talking about. Now, when you have gotten this one now, write it in standard form. It's now going to be 3.606 times 10 raised to power 3. Are you getting it? When you times it by 10 raised to power 3, you are going to get 3606. 3606. That's why the final answer is 3606. If you want to check whether you are correct, just use your calculator to multiply 85.14 by 42.36. You will get the same answer as this. So that is what we are talking about. I believe you get this very right. Thank you very much. Now Hence, 63.75 square minus 21.39 is 3606. The end of the logarithm, this first part. I believe that you understand this, and then we'll meet in the next class. Thank you very much. You can rewind, fast forward, pause. Just know that you understand this, and I believe you are going to get it. What I want you to do now is to go and find a four-figure table and follow exactly what I have told you. When you want to look at the number, you look, if it is logarithm, go to logarithm aspect, look at the number under what and in what difference. When you get that one, you'll be able to locate the right number, add them together as the case may be, and then do the certain operations according to the principle of logarithm. I believe you will enjoy this. We'll meet in another class. Don't forget, subscribe to our YouTube channel. You will be seeing better valued mathematics and other subjects course that will help you. I wish you excellent. Thank you.